Hello everyone and welcome to this first video on the sliding window series where we're going to be looking at the problem maximum average subarray 1. Let's try to look at the problem statement and understand it. We are given an integer array nums consisting of n elements and an integer k. Out of all the k length subarrays that exist, we are supposed to find out the maximum average. Let's look at example 1. Here we have a nums array and a k. If I ask you what are all the 4 length subarrays that can exist in this array, you will say the first 4 length subarray is nothing but 1, 12, minus 5, minus 6 as I've written here. The next k length subarray would be 12, minus 5, minus 6, 50 as I've written here. The last k length subarray would be minus 5, minus 6, 50 and 3 as I've written here. It is easy for us to individually compute the averages of these subarrays and find out the maximum average. In this case, the maximum average turns out to be due to this subarray because the sum of that subarray is 12 minus 5, which is 7, 7 minus 6, which is 1, 1 plus 50, which is 51, and 51 by 4 is 12.75, which turns out to be the maximum average, which is what we want to return. Let's try to solve this problem by the concept of fixed size sliding windows, which I'll be explaining right now. Let's take the example of an array 1, minus 1, 3, 4, and let's say 5. The indices are 0, 1, 2, 3 and 4, and let's say k equal to 3. Now if I ask you to list out all the k length subarrays, you would say the first k length subarray is nothing but 1, minus 1, 3, consisting of the indices 0, 1, 2. The next k length subarray would be nothing but minus 1, 3, 4. The first k length subarray is this, the next k length subarray is this, and then this is contributed by the indices 1, 2, 3. The last k length subarray would be nothing but 3, 4, 5. This is contributed by the indices 2, 3, 4, 2, 3, 4. So remember, these are the elements itself and these are the indices. Now if I ask you to compute the sum of each of these k length subarrays, the first sum would be nothing but 3, the next sum would be nothing but 6, and the last sum would be 9 plus 3, which is 12. Now if I want to compute the average of all of these subarrays, the first average is nothing but 3 by 3 because sum by k, or the number of elements, is nothing but the average, which is 1. Now 6 by 3, this average is 2, and 12 by 3, this average is 4. So the maximum average turns out to be due to the last subarray, and this is what we need to return. One first observation we can make right off the bat is that we don't need to compute the average for each subarray. If we just find out the maximum sum as 12, all we have to do is divide that maximum sum by k to get us the maximum average. That is the first observation. Now let's try to understand what is an efficient way to kind of compute this maximum sum. So let me tell you that let's say that you already have the first k element sum. So you already have this sum. In order to move from this sum to the next sum, what am I essentially doing? I am removing the element at the 0th index and I'm adding the element at the 3rd index. That is all I'm doing right now. Just to repeat, in order to move from the subarray consisting of indices 0, 1, 2 into the subarray consisting of indices 1, 2, 3, because if you look at this 1, 2 is already there here. All that is different is this 0 index element got removed and the 3rd index element got introduced. Similarly, to move from this sum 6 to the sum 12, or the subarray 1, 2, 3 to the subarray 2, 3, 4, all that's happening is this element is getting ejected and a new element, index 4 element, is being added. This is kind of the concept of the fixed size sliding window. If I already have, let's say, sum equal to 3, which is the sum of the first k elements, in order to move from the first k length subarray to the next k length subarray, all I have to do is sum minus equal to nums of 0, which is basically meaning that I'm saying sum equal to 3 minus nums of 0, which is the element at the 0th index, which is 1, that is 2. So right now I have the sum of these two elements here. Now all I have to do to these two elements ka sum is add the nums of 3. When I add the nums of 3 here, I get 2 plus 4, which is nothing but 6, and this is my new sum. All what I did was, as I discussed, remove the element at the 0th index, added the element at the 3rd index. This can be extrapolated to the next one as well, and I suggest you to pause the video and try that as an exercise. Now let's try to code this out. In order to code this out, I will have a simple variable called sum, and I will try to find out the sum of the first k elements. So I will say, what I have for index equal to 0, index less than k, and index plus equal to 1. So my index starts from 0, ends at k minus 1. and this will have the sum of the first k elements. Perfect. Now I also remember I need to find out the maximum sum. So let me have a variable called maximum, which is initially set to the sum of the first k elements, and depending on the sum of the other k length subarrays, I'll accordingly update this variable. Now my index is already traversed from 0 to k minus 1 because it already has the first k element sum. I need to compute the other subarray sum as well. So I have another for loop starting from index k, and this will go till n. Now remember that I have not defined n, and so let me just have int n equal to the size of the array. So we can just do nums.size to define the vector size. Now here, remember I need to do two things. I need to in order to move from one k-length subarray to the next k-length subarray, the current subarray's leftmost element needs to be ejected, and the current index needs to be added to move from the old subarray to the new subarray. So in order, for example, to make this clear, from 112 minus 5 minus 6 to move to 12 minus 5 minus 6 50, all I'm doing is removing this leftmost element and adding this element 50. Similarly, from this subarray to move to this subarray, what am I doing? I'm removing the leftmost element and I'm adding this element 3 here, because the remaining elements already are there. So why do I have to do repeated work? I can just do the intelligent fact, right? So I'm doing sum minus equal to nums of index minus k. So a few people might have a doubt that why don't we just do sum equal to sum minus nums of 0? So aren't we removing nums of 0 here and then adding nums of index? And that would be wrong, because even though it works for the first case here, if you look at the next case, right, I want to move from this subarray to this subarray, I should eject nums of 1 essentially. So you cannot hardcode that to be nums of 0. Initially you're ejecting nums of 0, then you're ejecting this nums of 1 here, and this loop works because see, k is 4 in our example here, and my index starts from 4. So initially 4 minus 4 is 0, so that is what gets ejected. In the next iteration, index gets incremented but k remains the same, so 5 minus 4 becomes 1, and appropriately 12 gets ejected here. Now ejecting is done, so I also need to add nums of index. These are two parts. In order to move from one k-length subarray to the other k-length subarray, I need to remove index minus k and add index. So that's what we're doing here. Now we also need to update our maximum, to make sure that we have the maximum sum with us. Now all that is left right now is directly to return the average, and average is nothing but maximum by k, because number of elements is fixed at k. Just to make sure that I'm returning a floating point value, let me just multiply it by 1.0 here. And the complexity of this approach would be, just O of n, because we're just traversing the size of the array. And yep, we got accepted. So yeah, thanks for watching, and let me know if you have any doubts or suggestions or improvements in the comments below. Thank you.